And good morning, everybody. Good to see you again. Well, maybe I'm not seeing you, but you're seeing me. Remember me, your old physics teacher. So today we are going to talk about and see cute little demonstrations about how each of the kinds of energy that we need to be paying attention to change. And those kinds of energies, again, are KE, kinetic energy, PE, gravitational potential energy, and internal energy, Q. So let's look at some little demos and decide which kind of energy changes and which doesn't. So first, I'm going to take this banana, lift it off the counter at a nice, slow, steady speed to my face so I can eat it. Now, which kind of energy changed through the lifting process? Hopefully you can see pretty easily that the kind of energy that would have changed there is the potential energy, the gravitational potential energy. We know PE equals mgh. I increase the h, so the PE must change also. Now, while it does have a little bit of kinetic energy on its way up, throughout the process, I'm not changing the kinetic energy because the velocity is staying the same or the speed staying the same, so KE stays the same. It might have some KE, but KE is not changing. So, increasing PE. Okay, now next let's look at changing kinetic energy. I have this awesome little car, doors open. We'll drive with the doors open. If I pull it back, there's a little spring. I store some potential energy rather in the spring. And then if I let it go, let's think about what kind of energy changes along the way. Okay, so until it smashes into the Cheerio box, we saw that the cart's speed picks up, increases the whole way. So obviously it should be pretty easy to see the kinetic energy is increasing there. Okay. Now it's not going up, it's not going down in terms of its height, so the PE doesn't change. PE stays constant. Okay. And let's assume that the wheels are pretty good, which they are when I give it a push. They're not terrible. So let's say that there's really no change. There's not much friction or resistance to work against. So there's really not much increase in the internal energy, maybe a tiny bit. But pretty much this is just an increase in kinetic energy while it speeds up. Okay, so next I'm going to take this delicious hot fudge. A lot of chemical energy in that, by the way, because it has a lot of calories. Saunders hot fudge from my home state, by the way, Michigan. Anyhow, I'm going to drag this along the table, or push it along the table at a slow, steady pace, constant speed. And which kind of energy, if any, would be changing there? This is a case where our internal energy would be changing. Why? Because friction was involved. Okay, if I give it a little push, it slows down almost immediately and stops because of friction. Whenever we have resistance or friction and I'm pushing along a surface, those surfaces are in contact, scraping together, warming up a little bit and scraping the metal and scraping the counter, which is not good. But that's an increase in internal energy. As long as I push at a constant speed, okay, I'm doing work, by the way, because I'm pushing it through a distance, but I'm not changing its kinetic energy, I'm not changing its potential energy, but I am increasing its internal energy because of the heating and the scraping involved. So there you have it. How to change each of the forms of energy in a very straightforward way. Now, by the way, you could change more than one at a time. It is very possible. We just looked at simple cases here. I hope that makes things simple and clear. Goodbye.